Okay, find y. So we already talked about that. When they give you a differential equation, the solution to the differential equation is the equation that can be plugged in place of y, and you would make this equation a true statement. They're asking us to find that equation. Well, whenever we are looking for the solution to a differential equation, we're using the SASE method. So I write down the equation. First step, you need to separate the variables. So I multiply the dx across, that gets me to here. I'm going to divide both sides by 3 minus y. That gets me to here, that's 1 point. I changed the order here to make using the antiderivative rules easier. 3 subtract y is the same thing as minus 1 plus 3. So that gets me 1 point. Next step is to find antiderivatives. So let's label these here. Let's see. Labeling's a little bit off. No, it's okay. So right here, we get 2 points for finding antiderivative. Okay, this antiderivative requires the use of the 1 over a, or the extended rule. So a is -1, b is 3. The rule says this antiderivative is 1 over a multiplied by natural log of ax plus b. On the other side, I'm taking the antiderivative of the cosine. So I look at my I remember my golden notes. I go right to Susie's circle, and I remember that the antiderivative of the cosine is the positive sign. Back to the problem. So the antiderivative cosine is positive sign. If I get that far, you get a point for that antiderivative and a second point for the other antiderivative. So 3 points total so far. Next thing to do, find the constant of integration, or in reality, I just have to remember to write the constant of integration. That gets me 1 more point. And here, so this is the process of constantating, finding the constant. That's this step. So to find the constant, I'm going to take my equation right here, and I'm going to use the fact that I know that's the equation for finding y equals something. It's just not rearranged. So I started with the equation for finding the rate, or the dy dx. I have now created an equation for finding the amount. It's just that my equation for finding the amount isn't in an organized pattern, and it also doesn't know c yet. But that's what I have, an equation for the amount. So the problem says my equation for calculating the amount has to be an equation where when you plug in x equals 0, the y value is 1. So I'm going to do that now. Take my equation, which was, let's see, pull that down a little. Move these out of the way. So my equation is negative natural log. I should have absolute value there. That's a mistake. Negative y plus 3 is equal to sine of x plus c. When the x value is 0, the y value is 1. So natural log, absolute value, y value of 1, x is 0. I remember my watch. So I look at my watch. Here's angle 0. Cosine is the across. Sine is the up and down. So at angle 0, I'm not going up and down at all. So sine of 0 is 0. This would be positive 2. Absolute value of positive 2 is 2. So my value for C is the negative natural log of 2. That will earn me this point right here. You actually get that point just for plugging in correctly, like that. So now I found C. Last point is to solve for y, to isolate. That's the I in SASE, isolate y. So you rewrite the equation for y, which is right here. Negative natural log, absolute value, negative y plus 3 must equal sine of x plus c. But c is negative ln of 2. I've got to get rid of this negative, so I multiply both sides by negative 1. The negative 1, when multiplied by this half, has to distribute. So when the negative 1 distributes, you get negative 1 multiplied by sine. But negative 1 multiplied by negative ln would be positive ln. Like that. Now I've got to get rid of the absolute value bars. That's kind of like square root. You end up with two possible results. Either what is inside the bars is going to equal exactly what you see here. Oh, wait a minute, I gotta get rid of the ln first, my bad. So before I get rid of the bars, I gotta get rid of the ln. So that means I need to use this rule. E to the natural log of whatever is just the whatever. So I take both sides of this equation and I make them exponents of e, like that. That gets me absolute value, negative y plus 3, because e to the natural log of whatever is just the whatever. That's got to equal e raised to the negative sine of x plus ln of 2. On an FRQ, I don't need to do anything with this, but on a multiple choice, I will have to change it to match their answer. So I'm going to show how that is done right now. So we're going to come over here so we have a little more space. Right here, we're going to use the fact that E, so right here, that blue to turn on. So right here, we're going to use the fact that E raised to the a plus b is the same thing as e to the a multiplied by e to the b. That's on the golden notes. First sheet, of course, is where most everything is. Right down here at the bottom. So using that, I can rewrite this equation as absolute value, negative y plus 3, must equal e to the negative sine of x multiplied by e to the natural log of 2. But remember, e to the ln of anything is just the anything. So now I have this. This is all equal to 2. Like that. Now to get rid of the absolute value bars, you must remember that you get two possible solutions. Either this right here, negative y plus 3, will equal exactly what you have on the other side of the equal sign. Or it is possible that this will equal the negative of all this. like that. To determine which of these two answers, this one or this one, is correct, remember, we're trying to find an equation of y equal. We're looking for a y equal equation that if we plug that y into here, this differential equation would be true. But we're also looking for a y equal equation so that when we plug 0 in for x, the y value is 1. So we're going to use that now. If I were to put a 1 in for y and a 0 in for x, we already talked about how the sign of 0 is 0. E to the 0 power is 1. 2 times 1 is 2. That is a true statement right there. So that tells me this is my correct equation. All I have to do is rearrange it. So that becomes y equals, because we're going to move the 3 and then we're going to multiply by -1. So y is going to equal 3 minus 2 e to the negative sine x. If you can get that equation, you get the final of the 6 points. 6 points total, that's equal 1 point. If I tried to find the solution here, it would not have worked, because putting a 0 in for x, I would get 2 times -1. That's not going to equal +2. So this was the wrong answer. This is the right answer, 6 total points.